For your AP Stats practice problem, we're going to do a free response from the 2012 AP Stats test. And the directions are: show all your work, indicate clearly the methods you use because you will be scored on the correctness of your methods as well as on the accuracy and completeness of your results and explanations. Number 1. The scatter plot below displays the price in dollars and quality rating for 14 different sewing machines. A. Describe the nature of the association between price and quality rating for the sewing machines. B. One of the 14 sewing machines substantially affects the appropriateness of using a linear regression model to predict quality rating based on price. Report the approximate price and quality rating of that machine and explain your choice. C. Chris is interested in buying one of the 14 sewing machines. He will consider buying only those machines for which there is no other machine that has both higher quality and lower price. On the scatter plot reproduced below, circle all the data points corresponding to the machines that Chris will be considering buying. Once you finish with your work, there is an answer key to the questions. So it is question 1, and it says the primary goals of this question were to assess students' ability to 1. Describe a nonlinear association based on a scatter plot. 2. Describe how an unusual observation may affect the appropriateness of using a linear model for numeric data. 3. Implement a decision-making criteria on data presented in a scatter plot. So the solution to part A for full points would be: the data show a weak but positive association between price and quality rating for these sewing machines. The form of the association does not appear to be linear. Among the machines that cost less than $500, there appears to be very little association between price and quality rating. But the machines that cost more than $500 do generally have better quality ratings than those that cost less than $500, which causes the overall association to be positive. Part B. The sewing machine that most affects the appropriateness of using a linear regression model is the one that costs about $2,200 and has a quality rating of about 65. Although the other 4 sewing machines costing more than $500 generally have higher quality ratings than those costing under $500, their prices and quality ratings follow a trend that suggests that quality ratings may not continue to increase with higher prices, but instead may approach a maximum possible quality rating. The 2,200 sewing machine is the most expensive of all, but has a relatively low quality rating, which is consistent with a nonlinear model that approaches a maximum possible quality rating and then perhaps decreases. If a linear model were to fit all of the data, this one machine would substantially pull the regression line toward it, resulting in a poor overall fit of the line to the data. Part C. According to Chris's criterion, there are 2 sewing machine models that will be considered for buying. 1. The model that costs a bit more than $100 and has a quality rating of 65, or 2. The model that costs a bit below $500 and has a quality rating of 81 or 82. The data points corresponding to these 2 machines have been circled on the scatter plot below. Here's an explanation of how the scoring for this question would be if it was a real AP Stats free response. So part A is scored as follows. Essentially correct, E, if the response correctly describes three aspects of association: direction, positive; strength, weak or moderate; and form, curved or nonlinear. They must also describe the association in context. Partial credit, P, if the response correctly describes two aspects of association in context, or if the response describes all three aspects of association without context. And incorrect, I, if the response fails to meet the criteria for E or P. Part B is scored as follows. Essentially correct, E, if the response identifies the correct point where responsible approximations to the price and quality values and gives either of the following two explanations. 1. The point is conjunction with the entire collection of points appears to have a curved or nonlinear form. 2. A linear model that includes all the points would result in a poor overall fit to the data, largely owing to the presence and influence of the identified point. Partial credit, P, if the response identifies the correct point with reasonable approximation to the price and quality values and gives a weak explanation of why the point affects the reasonableness of a linear model. The following are examples of weak explanations. 1. The point is an outlier. 2. Removal of the point makes the pattern more linear. 3. The point does not follow the linear pattern of the others. 4. A sewing machine this expensive should have a higher quality rating. 5. There is a much cheaper sewing machine with the same quality rating as this one. 6. The point has considerable influence on the parameters of the least squares regression line. Incorrect if the response fails to meet the criteria for E or P. And lastly, part C. Essentially correct if the correct 2 points are circled and no other points are circled. Partially correct if the correct 2 points are circled and 1 or 2 other points are circled. Or if only one of the 2 correct points is circled and at most 1 other point is circled. And incorrect if the response fails to meet the criteria for E or P. 4 points for complete response, all 3 parts essentially correct. 3 points for substantial response, 2 parts essentially correct and 1 part partially correct. 2 points for developing response, 2 parts essentially correct and 1 part incorrect, or 1 part essentially correct and 2 parts partially correct, or 1 part essentially correct and 1 part partially correct, but see the exception note with an asterisk below, or all 3 parts partially correct, and 1 point for minimal response. 1 part essentially correct and 2 parts incorrect, or part C essentially correct, part B partially correct, and part A incorrect, or 2 parts partially correct and 1 incorrect. That completes our AP Stats free response practice.